All right, guys, welcome to the vertex form of a quadratic equation. So we have been working with the standard form of a quadratic equation. And the standard form is the ever popular y equals ax squared plus bx plus c, where a, b, and c are integers, and a cannot be 0. But now you're going to learn a new form, okay? And this form is called the vertex form of a quadratic equation. And the vertex form of a quadratic equation is y equals a, there it is again, a, x minus h in parentheses squared plus k. And the reason why this is called the vertex form is because the h and the k are going to basically just tell us our vertex without having to do negative b over 2a. So h comma k is the vertex, and x equals h is the axis of symmetry. Keep in mind that in vertex form, this has to be subtraction and this has to be addition, which means if this is addition, the h is negative. And if this is subtraction, the k is negative. So again, in vertex form, this has to be subtraction and this has to be addition. This is the standard vertex form. So if these signs change, then the h and the k have different signs, have negative signs, all right? So taking a look at number 1, y is equal to x plus 4 squared minus 2, so the a is 1. All right, h is negative 4 and k is negative 2. So just remember that standard vertex form is default a times x minus h squared plus k. So since the h is positive here, then that means that that is a negative 4 because it minus to make that positive. And since this is a minus 2 and it's supposed to be plus k, then that k is a negative 2. Which means my axis of symmetry is x equals negative 4, and my vertex is negative 4 comma negative 2. Remember, the axis of symmetry is x equals h. We don't have to do negative b over 2a because it's not in standard form, it's in vertex form. So x equals h is my axis of symmetry, and h comma k is my vertex. All right, if we take a look at number 2, we've got an a of negative 1, an h of 3, remember it's a x minus h squared plus k. So since the sign in front of the 3 is a minus, and that is a 3, h is a 3, and then there is no k back here, so k must be 0. So my axis of symmetry is x equals 3, and my vertex is 3 comma 0. So x equals h and h comma k. All right, so go ahead and pause the video and try number 3. Try number 3, and then I will set up number 4 with you. Pause the video, try 3, and then we'll check your answer. Okay, hopefully you pause the video to try number 3. Your axis of symmetry will be x equals 5, and your vertex will be 5, negative 4. So x minus h squared plus k to give us those values. Now number 4 looks like it's in standard form, which it kind of sort of is, but we can rewrite it into this one quickly into a vertex form. Okay, just like this. Take a look what I did here. Instead of x squared, I wrote x plus 0 squared. And x plus 0 squared is exactly the same as x squared. So my h must be 0 and my k must be 3. So just keep an eye on something like that. If it is saying it's in vertex form and it looks like it's in standard form, except there is no b, like bx is missing, we can rewrite it into vertex form by rewriting the x squared into x plus 0 squared to show that your h is 0, and in this case my k is 3. So my axis of symmetry is at x equals 0, and my vertex is at 0 comma 3. Now we're going to go graphing these quadratics that are in vertex form, okay? They are not in standard form. They are not in the form we are used to, which is y equals ax squared plus bx plus c, which is standard. They are in vertex form, so they're in that hk form. So let's write vertex form here. Y equals a, x minus h squared plus k. So my a is -1, my h is -2, and my k is 7. Again, it's -2 because this should be minus, but it's positive, so this was minus 2. All right, my axis of symmetry is x equals -2. My vertex is at -2, 7. Let's put the vertex in the middle of the table. We already know how to do this kind of a table. So our vertex goes in the middle with our domain always being from -infinity to infinity for a quadratic equation. And then my range, well, let's see. My a is -1, which means that this parabola is going to be a downward facing parabola. My vertex is a maximum. So this is a maximum, which means 7 is the largest y value, since the vertex of -2, 7 is a max. 7 is the largest y value. So -infinity is the smallest, and 7 is the largest y value. There's my range. Now we want to build a table of values. So -3 and -4 and -1 and 0. We're going to plug in, I'm going to plug in -1 and 0, and then use symmetry to put in the y values here. So -1 plus 2 is 1, squared is also 1. So -1 plus 7 will make 6, which means this is also 6. Now let's put 0 into here. 0 plus 2 is 2, square that is 4. So -4 plus 7 is 3 and 3. Let's plot those and make sure we didn't make a mistake, because we should get a nice U-shaped curve. All right, so I went ahead and plotted my points. Got my beautiful parabola there with my axis of symmetry. And there is the parabola y equals negative, or quadratic, whatever. Y equals negative, parentheses, x plus 2 squared plus 7. So go ahead and pause the video and try setting up number 6, and then unpause the video when you're ready to see if your work matches mine. Do that now. All right, so I've got a is 3, h is 1, and k is 0. Axis of symmetry at x equals 1. Vertex at 1, 0 in my table. That is a minimum. That vertex is a minimum because my a is positive, which means that 0 is my lowest possible y value. So my range goes from 0 to positive infinity. And my domain of every quadratic is from -infinity to infinity. So once I've put my vertex in the middle of my table, I counted to get my -1, 0, 1, 2, 3, plugged in 2 to output 3, which means that's also 3, plugged in 3 to output 12, which means -1 is also 12. You can check that if you'd like. Now 12 is not on here, so I kind of tried to count to 12. But I do have these 3 points. I have my vertex and then the 0, 3 and the 2, 3 to get a nice narrow parabola, real narrow here. And I knew it was going to be narrow. You're going to learn this soon because that 3 is, because it is a 3, it's a pretty decent sized number in this parabola world. So it's going to make a narrow parabola. And we'll talk about that soon. And then there's my axis of symmetry. So that is your introduction to vertex form of a quadratic equation. Thanks for watching.